All right, so let's look at example 1 together. The instructions say use a graphing calculator, or if you're at home, you can use Desmos. Use a graphing calculator to complete a table, draw a graph, and identify roots. So for example 1, everybody's going to need to grab the calculator on your desk and turn it on. Then we are going to start by entering our function in. So click y equals, that's on the top left. And if there's anything written on this page already, you'll want to clear it out. And there probably is stuff there because we've been using these calculators in other classes all day. So clear that out and type in this first function, x squared plus 4x minus 5. Click graph. If your graph doesn't look like the window is set in the right place, if you're not getting a good full picture of your parabola, you might need to click zoom, which is in the top middle, and then adjust. So you could either zoom out, you could zoom in. I usually like to start with zoom standard, which is the 6th line down. Zoom standard will make your window, it'll center it, it'll make it go from -10 to +10. That's usually a really good place to start. So take a look at zoom standard, see if that's a good window. And if that's working okay, we'll just leave it like this. So I think zoom standard looks pretty good on this parabola. What we want to do now that we can kind of see what it looks like, is we basically want to copy this graph down on the graph on our paper. But we also need to make a table. So you can go back and forth between the graph view, which we're looking at now, or the table view. To look at the table view on your calculator, hit second table. So you're hitting the blue second button and then the top right button on your calculator where it says table, the blue label. And that'll give you a table and you can kind of scroll up and down. So I want everybody on the table menu right now. And I'm going to ask you all to scroll up so that you can see the x value of -10. Can I get a volunteer to tell me what y is equal to when x is -10? Connor, do you see it? It says 55. Does everybody see that? You all have that on your screen? Start scrolling down. Watch the y values go from 55 to 40 to 27, 16, 7, 0, -5, -8, -9, -8. Did you see something happen there? We were going down. We were going down and down and down from 0 to -5 to -8 to -9, then back up to -8. What happens there? When you're going down to -8, -9, back up to -8. What's that point, that -9 point? What do we call that? That's our vertex, exactly right. So think about what's happening here. We're at -8, we go down to -9, and then we go back up to -8. That represents that point of our parabola right in the middle where we have a bottom and then it goes back up. That's our vertex. So when we are scrolling through our values on our table, on our calculator, trying to decide, well, which of these do we put on the homework sheet? Try to use the vertex or something around the vertex. Try to put that in the middle of your table. So that's the point, -2, -9. I'm going to put that right in the middle of my table. So that way, my table values have a little bit from each side. So then my x values will be between -5 and +1. That seems like kind of a good spread. So this is just a tip. You do not have to do it this way. But it's a really good idea when we want to look and see what a parabola looks like to have some values from the left side of the vertex and from the right side of the vertex. So this is just a bit of advice. Try to find that vertex point and put it near the middle of your table. That way you get to see what both sides are looking like. So use these entries on your table to fill in your sheet here. So my points are -5, 0. That's supposed to be a 0. -5, 0, -4, -5, -3, -8, -2, -9, -1, -8, 0, -5, and 1, 0. So these are the values that I can see from the table. We can use this table that we just wrote down to draw our graph. Or we could also just look at the graph on our calculator. So you could hit the graph button and you could look at it again and you could kind of copy it down. So whichever way you prefer, but make sure your graph is accurate. We have the points -5, 0, -4, -5, -3, -8, -2, -9, and then the pattern kind of starts repeating itself going up in the other direction. Remember, these are symmetrical, so once you get to your vertex, it's just going to flip and go in the other direction, but it'll be exactly the same. And once you have enough points drawn that you can get a pretty good image of a parabola, connect those points with a curved line, a U shape. And there we go. We have our table. We have our graph. We have one job left. The instructions also told us to identify the solutions. So we have options on how we're going to do that. Solutions are x-intercepts. They are also, we could also think of solutions as the x values that give us y values of 0. So if you're looking at your table, your solutions are going to be these here where your y values are 0. If you're looking at your graph, the solutions are the x-intercepts, the places where our graph crosses the x-axis. So a few different options on how to approach the solutions. All we're going to do is we're going to come over to the left-hand side of the page, and where it says solutions for number 1, we're going to write those two x values, -5 and +1. Those are our solutions. So this is all we're doing for numbers 1 through 6. You're going to practice using your calculator to draw out a table, draw out a graph, find your solutions, and this probably won't take you very long as you get faster and faster and faster with your calculators. So I want you to work on 2 through 6 on your own, and I'll be here to help you as you're doing it. In the meantime, I want to spend just a moment with Desmos. So let me stop sharing this screen. Or no, I will share the screen. We'll just use Desmos. So this is mostly for virtual students at home, but in-class students, if you're ever doing homework over the course of the week and you're at home and you don't have a graphing calculator, you might have to use Desmos too. So if you are curious about what this would look like on Desmos, take a peek at my screen. For number 2, we are using the function x squared minus 2x plus 1. So you can use just your keyboard to type those in. And then, let me see if I can screen right here. Okay, so if you're using Desmos, Desmos won't really create an awesome table. It does have a table creation function, but it's not as good as the graphing calculators. So instead of being able to just create a table of values, you'll probably have to look at the picture of the parabola, identify some points like this point, this point, this point, and actually try to just make a table of values based on some points that you can see. Yes, I heard a voice. Give me 1 second to turn my volume up. Yep, do you have a question?
Yeah, so I was kind of messing around Desmos, and where it says like the you put like the settings button.
Yes, right? It looks like a little wheel.
Yeah, hold on. hold on, let me rewrite this. Okay.
So that function will let you create a table. So if you click this little settings button, there is a table option. It looks like a grid and says convert to table. The problem is the table that you're converting to won't necessarily have enough values, and it also won't necessarily be centered around your vertex. This one just so happens to have the vertex on it, but they won't always. And so you might be looking at a portion of the table that's like kind of way off of the center of your parabola. So the table function on Desmos is not usually as robust or as helpful as the one from the graphing calculator. So it might be better just to actually look at the graph itself, the picture, to create the table.
Also in the X spot, you can rewrite the numbers. Like 35 and
Can you now? Let's try this again.
Yeah, I was messing around on
X squared minus 2x plus 1. So we go back to table. So you can change the numbers here. Okay, so I could put like 4. Okay, yeah. That is cool. So you could adjust these numbers if you type in something different for x. We could look at negative 12. You can also do what?
You can also add more. Like after the 2, you click enter, a space down. You can also add more.
Oh, I see. Okay. So to let you keep adding values in other places. Okay, so maybe this table actually will work just fine. So just to recap, I found this by clicking on the button that looks like it says like a settings button, a little cog, a wheel. Clicking the table button, which looks kind of like a grid. So it's this settings button, then the table button. Yeah, so that might help you create a table. And then when you want to identify your solutions or find your solutions, you're just looking for your x-intercept, and you can see that right here on the graph. You can often even click on it or hover over it, and the point itself will sort of light up and show you what the exact values are. So that's pretty helpful. So Desmos really does a lot of the work for you. The problem is when you go to take the ACT in a couple of years, you guys will be allowed to use calculators. You will not be allowed to use Desmos. So I don't want you getting too used to Desmos. And we do need to learn these calculator skills. So while you're here in the classroom, I want you using the calculators. But if you have to do some stuff at home, you feel free to use Desmos. All right, so keep working on these examples. If you got finished early and you want to try numbers 7 and 8, then by all means go for it. But we'll probably do a few more of the examples from this skills practice together in class, but we will definitely be doing number 7 and number 8 together at the end of class. So give those a try if you can get to them in time. But also keep in mind we'll be going over them in a little bit. All right. Are there any questions before we start going over these problems? Is anybody having any issues getting your calculator to cooperate with what you're trying to do? One thing to keep in mind, I should have reminded you of this earlier, but I forgot. One thing to keep in mind as you're trying to use your calculator to explore these quadratics is if you forget what to type into your calculator, you can always flip back to Monday. On the bottom of Monday's page is a list of instructions for making a graph, for making a table, and for calculating your zeros. So 3 different things we learned how to do yesterday. The instructions are all listed out. So we're not going to have enough time to go over these problems in extreme detail as a class, but I am going to just briefly go over them so you can compare your work to my work and make sure that you at least had something pretty similar to what I'm about to show you. So let's start with number 2. In number 2, we should have ended up with a parabola that looks something like this. I'm not going to draw the whole thing, but our parabola should be about this shape, and it should go through the point 1, 0. So this right here was our root, and it also happened to be our vertex, so it was probably right in the middle of our table here. So one of our points was 1, 0. That means your solution is 1. And there's only a single solution for this problem. You know, some problems only have one root, so we just have one solution. Number 3 was a little bit tricky because as you created your table and started to draw your parabola, you might have noticed that our vertex was down here and our parabola headed in the downward direction. So it actually never crosses the x-axis at all, which means that this one has no solutions. So up here on the line for the solutions for number 3, you could write no solution. You could also write no roots. That would be fine. They mean the same thing. And you would have a bunch of table values here filled in as well, probably centered around your vertex, which was 1, -2. Okay, let's take a look at number 4. In number 4, once you type this in, I ended up with a graph that has a vertex way down here. It looks like 5, -9. All the way down here. And it headed in this direction. And it intersects all the way up here. So this is what my parabola looked like when I put it into my graphing calculator. So some of the values on our table might have been our vertex at 5, -9, and these two really important points as well were probably on your table. The ones with the y values of 0, those are our x-intercepts, so those are our solutions. So our solutions to number 4 should have been +2 and +8. Any questions about number 4? All right, for number 5, we put this into our calculator. We take a look at the graph. My graph looks like this. So there's a parabola that faced down. It went through our x-axis in 2 places. So these 2 intercepts are our solutions. Your table would have also included a few important points like the vertex, 0, 9, or maybe these x-intercepts, -3, 0, maybe +3, 0, would have shown up on your table. And our solutions, therefore, are just -3 and +3. One more of these examples that I just want to look at really quickly. We have -3x² + 6x. When I draw this on my graph, I'm only going to draw a part of it here. We have this point, and this point. So our parabola should look something like this. It crosses our x-axis at 2 different places, here and here. And those were on our table probably here, 0, 0, and 2, 0. So these 2 points were our solutions, which makes our answers 0 and 2. Remember, we're using the x values. So the x values there were 0 and 2. So you might not have been able to get through all of these, and that's okay. These take some time, and we're just now starting to explore with these calculators. So we'll get faster at it as we practice using the calculators more and more. But as long as the graphs you were getting are looking pretty similar to mine, it sounds like you're probably doing everything right. And it's just a matter of becoming more fluent with the calculator, which will speed us up. Okay, what I want to do is spend the last 10 minutes or so. We don't even have 10 minutes left. What I want to do is really quickly talk about these 2 word problems. Number 7 is about a projectile that's represented on this graph where our y-axis is the height and our x-axis is the time. The question is, how many seconds, which means time, so how many seconds will it take the ball to hit the ground? And hit the ground means height. So can I get a volunteer to tell me, if something's hitting the ground, at that moment, what is the height of that thing? Volunteer? 0. If something's hitting the ground, it's at a height of 0. It's on the ground. So what we're looking for is the moment when the ball is at a height of 0. Well, that means x-axis. So the moment when that height reaches 0 is the same moment that our parabola touches the x-axis. So that's what we're looking for. And the question is, what will the time be? How many seconds will that be? Well, that's the x value, time. So take a look at this graph. Try to estimate what that x value is. Probably x equals like 6.7 seconds, something like that. And don't forget your units. This is in seconds, so you'll want to have that as part of your answer. So although this was formatted like a word problem, it really wasn't a problem that we had to do a lot of thinking about. You just look at the picture, you find your x-intercept, you find your root, and that's your answer. Number 8 is exactly the same way. I promise. It's exactly the same as number 7. The only difference is they don't give you a picture. You have to make the picture on your calculator. So go to y equals and type in negative 16x squared plus 56x. And then click graph. And if you're looking at a standard window, then this graph is going to look awful. We're not going to really be able to see very much on this. You can, however, see where the graph is sort of crossing, but let's make this picture a little better. I'm going to show you how to do something that we haven't done yet. So this is new, so everybody perk up. We know how to zoom, right? But if we try to zoom in or zoom out here, our parabola is still going to be really skinny. Notice that my x values really only need to be in the positives. We don't need negative x values because we can't have negative time. So here's what I want you to do. We're not going to use zoom. We're going to use a different button that says window. Window is next to the zoom button on the top row. So click window, and your window probably looks like the x values go from negative 10 to positive 10, and the y values go from negative 10 to positive 10. We're going to change that. So instead of x min going to negative 10, I want you to put 0 there. So x min should equal 0. We don't need those negatives, so we're gonna make our window go from 0 to 10. But then our y values also don't need to be negative, so our y values are going to go from 0 min up to, we need way more. Did you notice how our parabola was going up off the top of the screen? We need to include more y values up at the top. So instead of 10, we want y max to be 100. So our x min is 0, our x max is 10, our y min is 0, and our y max is 100. And then click graph. Do you see something that looks a little better? You can actually see the whole parabola on your screen now. Use your eyes to estimate what time you think the ball hits the ground. Can I get a volunteer to tell me what time you think that happens? Maybe a volunteer I haven't heard from today? Marcus, what about you? Did you get a good parabola that you can see pretty easily on the screen?
I think so.
What's the x value where the ball is hitting the ground?
Like 3?
Yeah, it's kind of halfway in between 3 and 4. Let's call that 3.5. So the time that it takes for the ball to hit the ground is 3.5 seconds. So do you see that number 7 and number 8 were the same? We did the same thing. We looked at a parabola. We found the x-intercept, this point right here on the bottom right. We found the x-intercept. The only difference was in problem 8, we had to use our calculator to draw the parabola first. So that's really all these word problems are going to require you to do is draw the graph and look at it. And we can use a calculator to do that.